Alright guys, I just wanted to break some things down for you before this test. This in the PowerPoint slide is what's known as a phase diagram. So here, this basically is showing the different states, the solid, liquid, gas, under different conditions and the points in which they change phases. For instance, a solid into a liquid or a liquid into a gas or vice versa. And the lines also show points of equilibrium where both states of matter can coexist together. Now, if you notice here on the left, this is P for pressure, and underneath is T for temperature. So for instance, on the left here, the solid, solids exist under so the numbers aren't there, but this is just so you can get a visual. So the solids exist under a certain temperature and pressure, and under those conditions exists in that region of the graph. A liquid in the middle there, liquids exist under those specific temperatures and pressures. If you change those, or if it gets too low, then it will cease to be a liquid and it'll change states. If the temperature gets too high, then it will jump into a different phase, which is a gas. So the gas is all the way to your right there, that whole portion. So that's the pressure and temperatures at which gases exist. You increase the temperature or increase the pressure, then it will change the state that it's currently in. You will see arrows at the top there, equilibriums. The top left corner equilibrium point is where a solid and a liquid can coexist together at the same time under that specific pressure and under that specific temperature. The second equilibrium on the top right, the critical point there, that is the equilibrium point where a gas and a liquid can coexist together under that pressure and under that temperature. Now, you will also notice in the middle there a triple point. That triple point is interesting because that is the specific pressure and temperature in which a solid, a liquid, and a gas can all three coexist together at the same time. That's what you need to be able to describe for your test. Know that this is called a phase diagram and be able to label this, the two equilibrium points, the triple point, plus where the solid, liquid, and gas exist. Now, there's this heating curve. Be able to label this as well. As the temperature increases, the phases will change. It'll go from a solid to a liquid to a gas. If you decrease the temperature, now you'll see that in the red, the melting and vaporization. So as the temperature increases, the solid melts into a liquid. As the temperature continuously increases, the liquid will become a gas. That's known as vaporization. You reverse it and decrease the temperature, that gas will turn into a liquid in a process called condensation, and then if you can further decrease the temperature, that liquid will turn into a solid in a process of freezing. On the left hand side, it talks about these two different plateaus here. Now anytime you heat an object, you heat, say, an ice cube. So you heat an ice cube, it's a solid, okay? Well, it needs to turn into a liquid. Well, it takes energy to turn that solid into a liquid. We know the boiling point of water, we know the freezing points of water, we know all those different points. However, those are temperatures. If you were in my physics class, I would break this down to way deeper than what we will do in chemistry, but you know that it takes a certain amount of joules of energy to do these processes. So for instance, if you add 200 degrees of a fire to an ice cube, or say a solid ice or whatever it is, and that solid will not turn into a liquid until all the bonds break first. And so the ice will absorb that energy and it'll apply to first break all the bonds, and during that process, because it takes a certain amount of joules to break all the bonds, that it plateaus. And then once all the bonds are broken, then it'll turn into a liquid. And then if you further increase the temperatures, those liquids, it'll hit a threshold point at 100 degrees, and at that point, those bonds need to be broken again for that liquid to turn into a gas. It takes a specific amount of joules of energy to do this. I'm not going to give you those numbers because this isn't my physics class, but just know that that is why there's plateaus between the different phases. Now, for your test, definitely know all the terms in bold: sublimation, deposition, heat of fusion, freezing point, boiling point, vaporization, condensation, evaporation. Know those are matching. Know the unusual properties of water. Um, for any time we're talking about a solid, there's two structures. It's crystalline or amorphous. Crystalline is a solid is specifically arranged in a specific pattern, and an amorphous solid is that the particles are just randomly arranged. Like plastic is amorphous, or rubber is amorphous, and the particles are just arranged in it whatever way. Glass is the same way. Um, and so here, definitely know these unusual properties. Water is extremely fascinating. Look these over and check them out. Know those for the test. Surface tension deals with an imbalance of forces at the surface of water, because H2O underneath the surface are surrounded at a 360-degree angle. It's completely surrounded, the H2O molecules. However, on the surface, there's no H2O at the top. It's air. So there's no H2O at the top. And so really what's going on is H2O underneath the surface H2O is pulling down. It's pulling it down, and it's pulling it horizontally and vertically, but nothing up top. And so that imbalance of forces creates a surface tension to where bugs can now can crawl on water, because it takes a certain amount of weight and mass to be able to break that surface tension. A leaf can fall on water and not sink because of that surface tension. It's all about imbalance of forces. Know a little bit about viscosity, and that's a property of a liquid, and how honey is very viscous. But other than that, that is basically everything that's going to be on your test. So definitely review all this, know the charts and diagrams, and then you guys will be good to go. Good job this week, and I will see you guys later.